All right, we're going to start be talking about derivatives, and when we take the derivative, we call it differentiating. So in this section, we're going to call it differentiation. It's section 2.1, and I'm going to call it 2.1a because I'm going to break this up into two lessons. And in this lesson, you're going to learn about derivatives and the famous tangent line problem. You may not be able to understand the tangent line problem today, but I'm going to talk about it, and just listen and watch me talk about the tangent line problem. And as we go through the next month or so, this should become a little more clear. But for the lesson today, I'm hoping that you will be able to answer these questions when you're done. How do you find the slope of the tangent line to a curve at a point? How do you use the limit definition to find the derivative of a function? And how do you find the difference quotient? Okay, so here's the tangent line problem. A line that goes through a graph at two places is called a secant line. Okay, there's a bunch of symbols here, and this is going to get really confusing because there's no numbers for you to attach to, and some of our brains can't really stay in that abstract thought for very long. And I'm going to try to throw some numbers in here to kind of make sense to you. All right. So let's call C like 1. So this be like 1 comma f of 1. Okay. So this be 1 f of 1. And let's call this over here like maybe 2. So 2 comma 1, because we're going to take 1, we put it in our function, we get 2. I know proportionally this is not correct because I can't come up with good numbers with these proportions here. And this little triangle is called delta. It's a Greek symbol, a Greek letter, and it's a symbol for the change of. So we're going to talk about the change of x. In this case, just think of it as a little piece of x. Okay, if this is x, x is 2, then this is just a little piece of x. We're going to add a little bit more, like a point something. But it looks like I'm going to add a whole one here just by the proportion of the graph here. So if this x is 2, then we're going to add like 2 more to it, if that makes sense. And this over here, so this would be 2 plus 2, and this will be 4. And this be f of 4. And that will give you the height. I hope that makes more sense. Okay? So the slope of the secant line will be going through this point, like 2 comma 1. And then this will be 2 plus 2 comma f of 2 plus 2. And we can say whatever that is here. Maybe that's 3. Okay, whatever that is. Does that make sense? All right. So, in order to find the slope, we have a slope formula, right? So you're going to take the second y minus the first y, f of c plus delta x minus f of c over c plus delta x minus c. Well, you know that c minus delta x minus c, c plus delta x minus c, x2 minus x1 is just going to be delta x because the c's cancel, or you're going to get this difference here, right? You're going to get this piece here. So that's going to be my denominator. The numerator is the part that looks a little ugly. We're going to take this minus this, okay? So it's going to look like this. So this is my denominator, and this is my f of c plus delta x minus f of c, and that's my change in y. Okay. Now this is, we're going to start to develop the difference quotient here. We did this last year in pre-calculus. And we're going to do it again today. Okay. So this is my slope of the secant line. But look what happens if we slide delta x, if we let delta x go to 0. If we make delta x smaller and smaller, you see how I'm making it smaller and smaller? I'm sliding this point towards my x, towards my c value, and then pretty soon the delta x is going to be 0, and we get a point here that's tangent to my curve. And that's a tangent line. That's why we call this the tangent line problem. And we can either slide it in from the left or we can slide it in from the right. We can make the difference between the x, delta x, smaller and smaller until it's 0, right? We're trying to get to 0. We may not be able to get it to 0, but we're trying to get to 0. And both of these will have the same slope because we can slide it either way, from the right or from the left. And then we'll get to this point here, which gives me a tangent line. And then we can find the slope of the tangent line. In fact, we can find the slope anywhere on my graph using the tangent line. So here's the formal definition of the tangent line. Okay, and this is your formal definition of a derivative. And you have to know this because you have to know the little pieces of it, even though we have a really quick way to find a derivative, if you remember the power rule. Okay, we're not going to use the power rule today. So from now on, when you hear derivative, when you think of slope, it's going to be the slope of that tangent line. Okay, so here we go. And this is the difference quotient here. If we let the limit of delta x go to 0 of the difference quotient, we get the slope. Okay, derivatives. There are a bunch of ways to write a derivative, and that's because it's been developed kind of like different places all over the world. And Leibniz and Newton were given credit for developing calculus, and they kind of developed it at the same time, so we've got a lot of symbols. The most common ones are these first three, and your book will use any of these three, and you have to kind of get familiar with them, okay? So these are the three that you're going to see the most. You'll probably see this one too, d over dx of f of x, and these two are actually the same, okay? So these are just the symbols that we're going to use to talk about the derivative, or the slope of the tangent line. So let's find the slope using our definition of tangent line, the slope of a tangent line. So we're going to find the slope of 2x minus 3. Well, if you're thinking ahead, you go, hey, Mr. Ho, this is a line, and it has to be the slope of 2 here, y is equal to mx plus b. The slope is 2 everywhere on the line, so I don't care if you're talking about the point 2, 1. Everywhere the slope is 2. Well, yeah, we're going to be able to get that, but I want to show you how we do that, because this is a kind of a simple form of what we're doing, and it's going to get a little bit uglier, so let's start with the easy ones. So when you use the definition of the slope of a secant line, that means we're going to take the limit as the change in x goes to 0. We're going to let this go to 0. You notice I can't do a direct substitution because I'm going to get a 0 over 0. That's indeterminate form. So that means I'm going to have to play around with some algebra. So this is my c value, or x. So this is going to be 2 in here. All right. So that's going to be 2 plus delta x minus f of 2 over delta x. I'm going to let that delta x go to 0. In order to do this, this is going to be my first function here minus this again, except I'm going to put the 2 plus delta x in for x here and 2 in x there. This is real confusing, so just hang on with me. That's why we kind of preloaded you last year with this. So rewriting this whole thing here by putting c plus delta x in for this blob here, we're going to stuff in here, and we're going to get this. Then we're going to take this blob, we're going to stuff in there, we're going to get this. Okay, maybe pause this and take a look at it for a second until you can understand it, and then let it go again. Unpause it. Alright, so this part right here is this part right here, and then this part right here is that part right there. Okay, it means we'll just plug the 2 in the x and get 2 times x minus 3. We plug the 2 plus delta x in for x, and we get 2 plus delta x times 2 minus 3. Okay, doing some algebra here, we're going to distribute the 2 right? Combine my like terms, and these two cancel, and you're going to be left with 2 times delta x over delta x. The delta x's cancel, and you get the limit of delta x goes to 0 for 2. Now you can take the limit, plug the 0 in for x, delta x, there's no delta x, so that means that it's just 2. That means our slope for this line at this point is 2. Okay, like I said, we already knew that from the beginning, but this is just the work that makes it happen. All right, second example here. By the way, these are all copied straight out of your book. This is nothing that I created. Okay, so find the slope of the tangent line to the graph, and then we want to find the slope here and the slope here. Now, just by looking at it, I can tell you that the slope here is 0. Okay, it's a horizontal line, and this has some kind of negative slope here, maybe like a negative something, I don't know, negative more than -1. Okay, so we're going to find that using the definition of slope of the secant line. So we're going to take this blob, we stuff it in here, and we get this. You still with me? Okay, then we take that blob and stuff in there, we get this. Alright, so now this is where we start, and we're going to FOIL this out. Pause it here if your algebra is a little rusty. FOIL this out and see if you can get this. Okay, put c plus delta x times c plus delta x. You should be able to get this. Alright, then we just clean it all up, distribute this negative sign, make sure you put brackets here so that you don't lose the negative sign on the 1. That's the most common mistake right here. Then collect your like terms. Okay, the c squared minus c squared, that's gone. 1 minus 1, that's gone. So you're going to be left with these terms here. Now just remember, after you clean it all up, everything should have a delta x in it. If you have something left over without a delta x, you made a math error up here, some kind of algebra error. So now I'm able to factor out that delta x, and these cancel, and I get the limit as delta x goes to 0 for 2c plus delta x. Now, what do you do with this? Well, you know that whenever you can, you should try to plug in take your limit and do a direct substitution. Put in a 0 for delta x, and we get 2c. So this is a little different from the last problem because we just had 1 point, but now we had 2 points, so that's why I left it as c, because I'm going to do it here with 0, and I'm also going to do it again with -1. So at this point, this gives me the slope everywhere on my graph, no matter what the x value is. We just have to plug it in here. Since I have 2 points here, that means I'm going to plug the 0 in for x. Alright, so that the 0, because of this 0, for c, we put in a 0 down here, 2 times 0 is 0, so the slope at 0, 1 is 0. Well, what's the slope over here at -1, 2? Well, we take that -1, that x, c, and we plug it in here for c, and we get, at this point over here, it's going to be -2. That's what I kind of thought. This was about a -2, right? Be sure to refer back to the graph to verify the slopes are reasonable. Is that reasonable? -2 here and 0? Yeah, that seems pretty reasonable to me. Okay, let's try one here that's cubed. Okay, remember my derivative? It just says now, it's not talking about slopes anymore, it just says find the derivative. So we're going to use our definition of a derivative, and then we're going to take the limit as delta x goes to 0 for this difference quotient, plug my x plus delta x in both x's, and then plug an x in there in both x's. Okay, so we're going to end up with this thing here. This is the first function here with the x plus delta x put in for both of those x's, and then this f of x is just putting the x here, and that's just exactly the same. Okay, we're going to FOIL this out, or distribute this out. X plus delta x times x plus delta x times x plus delta x. And we're going to get this whole thing here. That's that thing right there. Distributing the 2, I get 2x plus 2 delta x Distributing the negative sign, I get negative x cubed minus 2x. And remember, if I did this right, everything should cancel. That doesn't have a delta x in it. So I cancel the negative 2x and a positive 2x and x cubed and x cubed. And we clean it up just a little bit, and we get this. Factoring out at delta x, we get this here, canceling my delta x. Now we're left with this. We're going to look at it and go, can I try to plug in that 0? 0 for delta x. Okay, put a 0 here and a 0 here, right? Only for delta x, not x. Don't get confused. So this goes to 0, this goes to 0, so I have 3x squared plus 2. Okay, I'm going to do one more because this gets a little complicated here. So find the slope at 1, 1. So we're going to use a difference quotient definition of the derivative, and we're going to plug in or substitute x plus delta x into this x here. And then this x goes substitute that in there. Okay, so how we have finished this, we've multiplied by the conjugate. Okay, multiplying by the conjugate. And then I get x plus delta x minus x all over this. Don't do anything, don't mess with that. Okay, you can see that that cancels. And remember, when you cancel a numerator and denominator, they become 1. They don't become 0. So x minus x is 0 plus 1. Okay, there's a 1 here. So now I have 1 over square root of x plus delta x plus square root of x. Now if you let delta x go to 0, this is 0, so you end up with 2 times the square root, because square root of x plus the square root of x is 2 square roots of x. Okay, and just we're just going to put in here that the domain has to be all positive numbers. There's no negatives in here. Okay, just be careful about that. So at 1, 1, you can plug in that 1 for x. What is the slope at 1, 1? Well, it's going to be 1 over 2 times the square root of 1, which is 1/2. Then what about at 4, 2? Okay, at 4, 2, we're going to put a 4 here, so that'll be 1 over 2 times 2 is 1/4. And this is discuss the behavior at 0, 0, at the origin. What happens at the origin? Well, we can't put a 0 here. What do you think is happening here? Okay, all right. As at 0, 0, what is happening to this slope, do you think? This slope is getting, as we slide this point, that's 1, 1, closer and closer to 0. What's happening to that slope? Can you imagine the tangent line? The tangent line is going to get steeper and steeper and steeper until when you get to the origin, it's going to be right on top of the y-axis, so it's going to be undefined. Okay. All right. Here's a couple of problems here, so for you to practice on. Just plugging into the difference quotient. This part of the PowerPoint is from trig, my trig lesson. So you can try and do this. Right, pause it right here and see if you can work it through, and then play it, and then you should be able to finish this. All right. Okay, here's another one. Pause it here, see if you can do it yourself, and then watch the video and see if you get what I got.